The last few sessions we talked about correlation and autocorrelation. We did regression lines, and we looked at like how autocorrelation is just really, really important for trading strategies, because a lot of the systematic trading strategies really bank on the fact that the previous returns are related to the current returns. And so because that's the case, and they may be related in complex ways, but somehow related. And because that's the case, then we can do a trade. And that's amazing. But before we actually move back onto trading strategies, and what I'm going to do is today I explain this to you, and then in the next session, we'll move back to trading strategies and specifically technical indicators, because even though, they're not necessarily always the best thing for trading strategies, they're still important to some extent to understand. So I'll talk a little bit about different technical indicators. But today, what I'm going to do is I show you the mathematical basis for position sizing. That's a really, really interesting topic. And hopefully we can cover this in the little time that we have. So what we'll learn is quite a bit of using NumPy and arrays and so on in an effective way. So position sizing is interesting because imagine this, right? So let's say you have a coin and you flip a coin and you got heads or tails. Yeah. Now, if you do 1,000,000 of those, we know that, it'll be just about 500,000 times heads. Let's just do this. Let's just build a coin flip. We can use numpy.random, and then there is this thing called randint, is a random integer, right? Actually, we can't use that because if we use, well, actually we could. So we go randint, and then we go from 0 to 2, because the 2 is actually excluded. This is a typical Python thing. So all we get is zeros and ones. And then we do 1,000,000, yeah? And so if we run this, we just call this flips. And so 0 is tails and 1 is heads, right? And so if we run flips and we take the sum of it, we should basically get around 500,000 every time, yeah? So we go sum flips. Pretty close to 500,000. We run it again, pretty close. It's always, pretty close to 5. In fact, it's amazing how close it is to 500,000. It's really just far less than 1% off. Look at that, only 13 off. 221. So, that's a typical coin flip. But now imagine this. Let's say you have a coin, but it's not perfectly heads or tails. It's actually biased. So it's actually such that it gets 51% of the time heads and only 49% tails. So you actually got a little bit of an advantage. You know a little bit what the coin might give you. Okay. Now the question is, if you had say an infinite number of coin tosses, let's say just like 100,000 coin tosses, and let's say you start with $1,000 that you could bet on heads or tails, how much would you bet on? Obviously you want to bet on heads, right? Because that's in your in your favor. How much would you bet on each coin toss in order to maximize your win after 100,000 coin tosses?